Hello student. So today I am going to discuss with the topic entropy. This is one of the topic in data analytics. Although the topic is taught in the class, but some student asked some questions. So I am going to record the video lecture and I'll share with you. So let us start with what is entropy first. Before entropy, one more word you try to understand, that is called self-information, okay, associated with an event. Every event, it has some information. Let us understand with examples. If I tell the event is sun rises in the east, what is probability that sun rises in the east? It is 1 because it is very much understood. Then there is no information because it cannot be a breaking news. It cannot be a news for us because it is very much understood. Why? Because occurrence probability is 1. So there is no information. This is our understanding. But on the other hand, if we tell what is the occurrence probability of getting rain in the city, so this occurrence probability may be 0.1. So it contains some information. Means you can write this information in newspaper that tomorrow is going to rain. People may be interested to know. But if you write sun going to rise in the east, no one will care about. Similarly, if you tell the occurrence probability of earthquake, it may be further very less, 0.001. So if you give the information to public, okay, public will be more keen to know that whether it is going to rain or not. Okay. So point is, lesser the probability of occurrence, higher the information associated with the event. More the probability of occurrence, lesser the information associated with this. Now we can formulate the self-information is negation of log of probability of occurrence of event E. Why this formula? Because if you plot it, you will get the plotting like this. If it is I, it is probability of occurrence. So this probability of occurrence will be maximum 1. Once it is 1, log of 1 is 0. Here the base of log is 2. And lesser the probability, higher the information. If the occurrence probability is close to 0, the information associated may be close to infinity. As our hypothesis is like that, that's why we formulated the information like this. So information associated with the event minus of logarithm of probability of occurrence. So this is where we can justify our hypothesis that if probability of occurrence is less, information will be more. If occurrence probability is more, close to 1, information is less. As I mentioned that if you mention that sun rises in the east in newspaper, no one will care about this because there is no information. Okay. Now coming back, what is entropy? So entropy is weighted sum of information. or expected amount of information associated with the event. And this is also a measure of uncertainty, impurity in data that we shall come later to discuss again. But as of now, entropy is weighted sum of information. So as it comes weighted, so multiply the information with pxi and log of pxi. Here I signifies the mode of occurrence. Some event may have more than one mode of occurrence. Let us say flipping coin may have two mode of occurrence. Rolling a dice, rolling a die may have it has 6 mode of occurrence. So here we can put I is equal to 1 to 6. So in minus of log of px is multiplied, it becomes weighted sum. The mean amount of information associated with the event is entropy. Now having this formulation, let us see some example and then we shall again relate with how is it related with impurities or uncertainty in the data. Let us have an example here. Okay. Rolling a die. It has 6 classes. So if this die is fair enough, then sorry. So each class having probability 1 by 6. Each class having its probability 1 by 6. So 6 times 1 by 6 log of 1 by 6, the value is 2.58. Now, let us have unfair die. Some class has different occurrence probability, like first 1 to 5 having occurrence probability 0.1, and the last one, the occurrence probability of getting 6 is 0.5. Now you compute the entropy, weighted sum of information. So 5 times 0.1 log 0.1, sorry, it may be a mistake, 1 by 10, it's 0.1. 1, 2, 3, 4, 5. And last one having probability 0.5. Now you see the total entropy is 2.16. Now here it is 2.58 and here it is 2.16. Now how it has changed the values? So the point is, once the die is fair enough, so it is more uncertain, difficult to predict, less predictable, more uncertainty and more impurities in the data resulted in higher amount of entropy. On the other hand, as some class of the event, the occurrence probability is different, reduces. So it became relatively more predictable, it became less uncertain and more pure. Impurity came down, that's why entropy also decreased. This is the idea behind how the entropy is related with uncertainty and impurities of data. One of the application is discretizing the continuous data. If you discretize a continuous data based on entropy, so our idea is, so discretize it in such a way that after discretization, the total entropy should decrease. Information gain should be more. So that will give better result of the discretization. Okay. I hope you have understood with this example. Okay. And uh, if you have any doubt further, then you can discuss or send me a message on the email. Okay, thank you.